For centuries, humanity has looked into the night sky wondering what might be traveling between the stars. Every new telescope has revealed astonishing discoveries, from distant galaxies to strange exoplanets. But every so often, something appears that challenges even our best scientific expectations. Recently, astronomers detected an incredibly rare object entering our solar system from deep interstellar space. Unlike ordinary comets and asteroids that formed around our own sun, this traveler began its journey around another star millions, or perhaps even billions, of years ago. Objects like this are exceptionally uncommon. Only a few have ever been confirmed, making every new arrival an extraordinary opportunity for science. Instead of studying material born within our own cosmic neighborhood, researchers suddenly have the chance to examine fragments from an entirely different planetary system. As soon as the object was discovered, observatories around the world turned their attention toward it. Powerful ground-based telescopes tracked its movement while space observatories, including the James Webb Space Telescope, prepared to investigate its composition in unprecedented detail. At first, everything seemed fairly ordinary. The object followed a hyperbolic path, confirming that it was not permanently bound to the sun's gravity. It would pass through our solar system only once before disappearing forever into interstellar space. But as scientists collected more observations, several unusual characteristics began attracting attention. One of the first surprises involved its brightness. Normally, icy objects become brighter as they approach the sun because heat causes frozen gases to escape, forming a glowing cloud known as a coma. This visitor behaved somewhat differently. Its brightness remained surprisingly consistent over time, prompting researchers to investigate whether its surface possessed unusual physical properties. That observation alone wasn't evidence of anything extraordinary. Nature often surprises astronomers with unfamiliar behavior. Still, it suggested this object might be chemically different from anything commonly found within our own solar system. To learn more, scientists relied on one of humanity's most advanced scientific instruments, the James Webb Space Telescope. Unlike traditional telescopes that mainly observe visible light, Webb specializes in infrared wavelengths. This allows it to detect tiny differences in temperature and identify the unique chemical fingerprints of materials covering distant objects. Every mineral, ice, and organic compound absorbs infrared light differently. By examining those patterns, astronomers can estimate what an object is made of without ever touching it. When Webb began collecting data, researchers noticed that parts of the infrared spectrum appeared unusual compared with many familiar comets. That immediately sparked scientific interest. Some experts suggested the object may contain rare combinations of frozen compounds formed around another star. Others proposed that billions of years spent traveling through interstellar space may have altered its outer layers in ways never before observed. Neither explanation breaks the laws of physics. Instead, both remind us how little experience humanity has with material arriving from completely different planetary systems. As additional observations continued, astronomers discovered that the object's surface reflected certain wavelengths of light more efficiently than expected while appearing darker in others. These differences may simply reflect an unfamiliar mixture of minerals, complex organic molecules, or ancient cosmic radiation that slowly changed the object's surface during its immense journey between the stars. Every new measurement became another clue. Researchers also examined the object's rotation. Preliminary observations suggested that its spin remained relatively stable over time. While many irregular asteroids tumble unpredictably, stable rotation is still entirely possible under natural conditions depending on an object's shape and history. The more scientists learned, the clearer one fact became. This visitor was scientifically valuable, not because it had proven anything extraordinary, but because it represented something incredibly rare. Every interstellar object carries information from another stellar system. Hidden within its chemistry could be clues about how planets formed around distant suns, what kinds of ices exist elsewhere in our galaxy, and how planetary systems evolve over billions of years. Of course, as often happens with mysterious discoveries, dramatic stories quickly spread across the internet. Some headlines claimed the object was an alien spacecraft. Others suggested it was an artificial probe sent by an advanced civilization. Those ideas captured public imagination, but professional astronomers urged caution. So far, there is no verified evidence supporting such extraordinary claims. Science moves forward through careful observation, repeated measurements, and evidence, not speculation. History has shown that many mysterious discoveries eventually receive completely natural explanations once better data becomes available. Still, that doesn't make this object any less exciting. Its greatest importance lies not in proving sensational theories but in giving humanity an unprecedented opportunity to study material that formed around another star. For the first time, scientists may be examining a messenger carrying chemical fingerprints from a completely different corner of our galaxy. And this is only the beginning of the investigation. Although the object has generated enormous public attention, scientists remain focused on something far more important than sensational headlines: understanding where it came from and what it can reveal about the universe. Every interstellar object is like a time capsule. Unlike planets, moons, or asteroids that formed around our Sun, this traveler began its journey around another star. Long before Earth developed complex life, it may have been drifting silently through the Milky Way, carrying materials untouched for billions of years. That alone makes it one of the most valuable scientific targets ever observed. One reason astronomers are so excited is the extraordinary capability of the James Webb Space Telescope. Webb can detect faint infrared signals that reveal the chemical makeup of distant objects with remarkable precision. By studying how light interacts with different materials, researchers can identify various types of ice, minerals, and complex organic compounds that are impossible to distinguish using ordinary visible light telescopes. Every observation helps scientists compare this visitor with comets and asteroids already known within our solar system. If its chemistry turns out to be significantly different, researchers could gain their first detailed look at how another planetary system formed. That would be a major breakthrough. Instead of relying only on computer simulations, scientists would finally have real physical evidence from another star's neighborhood. Naturally, discoveries like these often inspire bold theories. Some people have suggested that unusual brightness or stable motion could indicate artificial technology. While those ideas attract enormous public interest, astronomers emphasize that there is currently no verified evidence supporting such conclusions. No artificial signals have been detected. No signs of propulsion have been observed. No confirmed structures suggest engineered construction. Every unusual characteristic identified so far still has several possible natural explanations. This careful approach is one of science's greatest strengths. Researchers do not reject exciting possibilities, but they also refuse to accept extraordinary claims without extraordinary evidence. History has repeatedly shown why patience matters. Many discoveries that once appeared mysterious eventually became well understood after additional observations provided missing pieces of the puzzle. That process is exactly what scientists are following today. Meanwhile, this remarkable visitor continues racing through our solar system. It will not remain here for long. Once its close approach is complete, it will continue its lonely journey between the stars, perhaps never passing another planetary system for millions of years. Before that happens, observatories across Earth and in space are collecting as much information as possible. Every spectrum, every image, every measurement adds another small piece to an enormous scientific puzzle. Perhaps the greatest lesson from this discovery is not whether it proves something extraordinary, Instead, it reminds us how little we still know about our cosmic neighborhood. Only a few interstellar objects have ever been observed directly. With such a tiny sample, every new visitor has the potential to reshape our understanding of planetary formation, chemistry, and the history of our galaxy. Some may resemble familiar comets. Others may contain completely unexpected materials. Future discoveries could reveal objects unlike anything humanity has ever imagined. That possibility alone keeps astronomers searching the skies every night. Somewhere beyond our solar system, countless worlds continue forming around distant stars. Asteroids collide. Comets are scattered into deep space. Entire planetary systems evolve over billions of years, sending small fragments wandering across the galaxy. Occasionally, one of those fragments reaches us. When it does, it carries a story that began around another sun. Whether this particular visitor ultimately proves to be an unusual comet, an ancient asteroid, or something that challenges existing scientific models, it has already achieved something remarkable. It has reminded humanity that the universe is far larger, stranger, and more connected than we once believed. Every discovery pushes the boundary of knowledge a little farther. Every new observation replaces speculation with evidence. And every mysterious object encourages us to keep exploring. Because history has shown that the greatest scientific revolutions rarely begin with answers. They begin with questions. As the James Webb Space Telescope continues studying the distant universe, one thing is certain. The next extraordinary discovery may already be traveling silently through the darkness, waiting for humanity to notice it.